discussing about the DT-based group activity under the topic of finite element analysis. So let's start the group discussion about the finite element analysis.
Myself, Hare Krishna. Now we're going to see about what is mean by finite element analysis. Finite element analysis is the type of analysis which we used for analyzing a whole structure-based project, a project or a product into a small readable parts. The parts are known as elements, and the connection between the parts are known as nodes. And finite element analysis help us to calculate the mathematical structural analysis of the product, and we can easily calculate the area and also a stress and strain analysis. By finite element analysis, we can easily design a product from base to final product, and this is known as
Now we'll see the processes of which is going in FEM, that is finite element analysis. So first starting with pre-processing. So here what we'll do is we'll take the whole material and we'll divide it into small elements and small pieces. So it will be easier for us to process, to simulate the results easily if it is small elements. And the next is boundary conditions. Here we will assign some conditions like we use force or stress or pressure or temperature. We'll design an environment in which the element will be there, and the next is where we simulate it, and all these forces, all these magnitudes of forces, pressure and temperature. What will do is that it will be converted into a mathematical equations. So these equations will be used to recreate the virtual copy of the real world material, and it will give us results. The final is result. So what we'll do is it will tell us how safe it is, and how applicable it is, and how efficient this material will be if we have to optimize it.
So continuing the topic, let us see the application of FEA, finite element analysis, mainly in engineering field. In automobile industry, we can use finite element analysis for car crashes and testing how the car withstand for maximum forces. And then we can go to civil engineering. We have tested buildings and then designing the component structures. Then we have go to aerospace engineering. We mainly check aircrafts parts, and we have designed spacecrafts.
So I'm going to talk about the advantages of using FEA. So there are many factors that make FEA more advantageous than physical testing. The primary factor would be that when you are using FEA, you won't do any tests on physical model of the specific design. We will create a 3D model and we will design and simulate the part in that software, and you get results approximately to the real world applications and designs. And the FEA is mainly used to find weak points in a structural part of an design and rectify it or optimize it by using any topology optimization or manual optimization. Then again, FEA uses finite element analysis, which takes every finite elements in that part and makes simulation in every parts to make it more accurate and more decisive in the end result. And,
Yes. So as we said, that is called as the separation is called as the mesh. Okay. So as a workbench. Okay. So the simply element we call as a mesh. So the mesh is nothing but it's like a 0.5 or 1 or 2 or 3 if you give it certain value. So based on the value, the element can be segregated or separate. That's what you said is the element and nodes. Okay. Based on the value, the solution is only approximation, not an accurate result. Why? Because if you change the mesh value, the correspondingly the stress and strain value, other parameters like a heat or whatever dynamic analysis we go applying now, so that is also changing corresponding. So it is only for the okay, when you go in the any original product, before that you can checking and software testing. Okay, not creating any prototype or they're going for this. Before that, you can using the software is will be using for that. Okay, so that's why it's the main objective of this DD based calculation. Thank you.
Thank you.